Boundary description using segment sequence. Boundary segmentation into segment of continuous curvature or curve segmentation into circular arcs and straight line is used. Segments are considered as primitives for syntactic shape recognition procedure. Here in the given image, different types of arcs are given, or the image is defined by 4 types of arcs and straight line that are defined for A, B, C and D. Here in the image, the starting point is given. According to that, the code word is calculated as D, B, A, B, C, B, A, B, D, B, A, B, C, B and A, B. B-spline representation. B-spline is basis spline. In the given image, P0, P1 and P2 are control points. So, curve is according to that control points. Curve shape is depend on control points. Now, before starting B-spline, we'll see what is Bezier curve. If this curve is near to the control point, it's called as approximation curve. Now, let us consider this as a Bezier curve. Bezier curve is parametric curve, that is, we can control the curve by some parameter. Here the control parameter we are using is u, and that u value is varying from 0 to 1. That means u is any value from between 0 to 1. Now let us consider a one curve from P0 to P1. Now, depending on u value, the curve position is defined. Now, if u is equal to 0, it is exactly on P0 point. If u is a 0.25, it is in between P0 and P1, and so on up to 1. When u equal to 1, the point is exactly P1. Now let us consider Q0 is any point or the position is in between P0 to P1, and we need to calculate what is that Q0 position. Similarly, we have to define what is a Q1 is in the between P1 and P2. So the equation for Q0 is 1 minus u x0 plus u x1. Now, from where we are getting this equation of Q0? Now, let us put u equal to 0 value in the equation 1. So, as we put u equal to 0, we are getting Q0 as x0. And as we go on increase the value of u, and when we put u equal to 1, we are getting exactly Q0 is equal to x1. If the value is in between 0 to 1, we are getting any one point in between P0 and P1. Similarly, we have calculated the equation for Q1, where Q1 is a point between P1 and P2. That's why we are getting the equation for Q1 as 1 minus u x1 plus u x2. And let us consider this as a second equation. Now, let us consider for a complete curve. Let C of u is in between Q0 and Q1. So, as we have calculated the equation for Q0 and Q1, let us define the equation for C of u. It is equal to 1 minus u Q0 plus u Q1. Now, as we are putting the value from u equal to 0 to 1, the C of u is varying. Now, by putting equation 1 and 2 in equation C of u, we are getting a final equation as C of u is equal to 1 minus u bracket square x0 plus 2 u 1 minus u x1 plus u square x2. Now consider if three control points are there, then the 2-degree polynomial is generating. We know that here we always get the n-degree polynomial with n plus 1 control points. That means if 4 control points are there, then we are getting a polynomial of degree 3. If 3 control points are there, then we are getting a polynomial of degree 2. Now let us consider here a 3 control points. That's why we are getting a polynomial of degree 2. In above equation, the polynomial is of degree 2 because we have a 3 control points. Now P0 and P3, P0, P1 and P2 are the interpolation point through which the curve is passing, where P0 is x0, y0, z0, P1 is x1, y1, z1 and P2 is x2, y2 and z2. The equation of Bezier curve is x of u. This is the same equation which we have calculated as C of u is in the standard form or in the summation form. Generalized equation is x of u is equal to summation of I equal to 0 up to I is equal to small n nci 1 minus u raised to n minus I u raised to I x raised to I, where u is varying between 0 to 1. Now here nci, the first term is binomial coefficient, whereas x0, x1, x2 and x3 are the coordinates and 1, 3, 3 and 1 are the coefficients. Now let us see what is exactly difference between the Bezier curve and the B-spline. Now here 4 control points are given, P0, P1, P2 and P3. Now curve is drawn for that control points. Now if I am moving only a single control point from P1 from one position to another position, that is P1, then as we are changing even a single point, there is different in the shape of complete curve, where in B-spline when we are moving a P1 from one position to another position, the effect of that P1 is not affected on a complete curve but on the part of curve. That is main difference between Bezier curve and B-spline curve. Another difference is if n control points are there, then we are getting, if 4 control points are there, then we are getting the equation of 3. If 4 points are there, then we are getting a polynomial of 3 degree. But here we need to define that k point in the B-spline curve. Now let us see what is exactly B-spline in detail. Let us compare the equation of Bezier curve with the B-spline curve. X of u is equal to summation of I equal to 0 to I equal to 1, n nci 1 minus u raised to n minus I ui xi where u is varying from 0 to 1. This is the equation for Bezier curve, whereas x of u is equal to summation of I equal to 0 to I equal to n nik u xi, but u is varying from 0 to n minus k plus 2. Now let us consider n is equal to 5. N is what? The control points, and k, we need to define that k, that is order of the equation. Now in Bezier curve, it is directly depend on the control point. If 4 points are there, the order is 3. But here in B-spline, we have to give the order, or we need to consider order k. So let us consider one example. When n is equal to 5, that means 6 control points are there, and k equal to 3, that is order. So u is varying from 0 to n minus k plus 2. So we are getting n minus k plus 2 as a 4. So the value is a 4, that's why u is varying from 0 to 4. That means a complete curve is divided into 4 segments, and these are from first segment is from 0 to 1, second segment from 1 to 2, third segment is from 2 to 3, and the fourth segment is from 3 to 4, as given in figure. P0, P1, P2, P3, P4 and P5, 6 control points are there, and the segments are given here: 0 to 1, 1 to 2, 2 to 3 and 3 to 4, and curve is also defined. Now, how S-plane is a local propagation? Whereas Bezier curve is global propagation, and S-plane is local propagation. Why it is so? Because even if a single point, control point is moving, a complete curve is moving, that's why it is called as a global. But in B-spline, even if single control point is moving, a particular or part of curve is changing or moving. Now let us consider a first segment where u is equal to 0 to 1. Now we'll just consider a first segment is varying from 0 to 1. Therefore, it's influenced by P0, P1 and P2. There is no effect of points on P3, P4 and P5. Now let us consider a second segment. Here the second segment is from 1 to 2. Therefore, it's influenced by P1, P2 and P3. Why we consider only 3 points? Because our order is 3. That's why it is influenced by P1, P2 and P3. And therefore, there is no effect of the points P0, P4 and P5. Similarly, for third segment, which is from 2 to 3 point, it's influenced by P2, P3 and P4, and there is no effect of point P0, P1 and P5. Now consider fourth segment, which is from 3 to 4. Therefore, it is influenced by P3, P4 and P5, and there is no effect of point P0, P1 and P2. Now, if P2 is changes, its effects on second and third segment only. There is no effect on first and fourth segment. Therefore, here we can observe in the image, P2 control point is changing from one position to another position. The previous curve was drawn by pencil, and here the blue curve is a new curve. In this, there is no effect on the first part and the last part. Only the middle part is changing. Now, let us consider this using a exactly equation. For n equal to 5, the Bezier curve equation is x of u equal to 1 minus u raised to 5 x0 plus 5 1 minus u raised to 4 ux1 plus 10 1 minus u cube u square x2 plus 10 1 minus u square u cube x3 plus 5 1 minus u raised to 4 x4 plus u raised to 5 x5, where u is varying from 0 to 1. Now similarly B-spline for n is equal to 5 when we consider k equal to 3. The equation is x of u is equal to n03 u x0 plus n13 u x1 plus n23 u x2 plus n33 u x3 plus n43 u x4 plus n53 u x5. Basis function moves from n03, n13 up to n53. If we elaborate it, we'll get a different equations.